No, it's just on the screen. So welcome to calculus. This is a practice quiz. We're going to try to do 7, 8, 9. Maybe we'll get the related rate 10 in there. 4 problems. Everybody, number 7 says find the equation of the tangent line for the given function at the given point. Immediately you should be thinking instantaneous rate of change, which means derivative. And with our new rules, this is a gimme. There's the derivative of y. We evaluate at the x value. So I would write f prime of -1 is 2 times -1 plus 1. How about -1? You guys all agree? Guys, we have a slope. It's -1. We have a point. I will use point slope form. So y minus 2 equals -1 times x plus 1. Done. If you're doing y equals mx plus b, stop and practice this. When you get to college, this is so much faster. All right, you might as well take it now. Learn it now. All right, everybody. It says find d squared y dx squared. First of all, you practice enough, you know that is the second derivative. The reason that's the second derivative is it's this, guys. Look, you can see the exponents make complete sense when you do it this way. d dx of y, and then d dx of d dxy. So dy dx is -8x cubed. You guys all agree? First derivative. And then I do the second derivative. I do, watch, I'll show you in green. Ooh, I do d dx of the red. And I get to the second derivative is, what, -24x squared. All right? All right. That takes us to number 9. We're cruising, watch you. All right. There are, what? Looks like there's 6 conditions here, right? 1, 2, 3, 4, 5, 6, 7. I lied. 7. All right. Everybody, I make my grid. -2, -1, and 4. All right. Everybody, first one we'll do in green. At -2, the limit is, when you're at -2 for x, the limit is 3. Boom, boom. There's that. The next one says when the function when it's 2 is 5. Boom. All right, and I guess I should mark 3, right? I suppose I should mark 5. Oh shoot, +2 is equal to 5. I missed that. +2, so that point is over here. Yep, my bad. I think I meant for it to be -2. I think my answer key assumes it's -2. I read what I wanted. Limit as -1, as you approach -1 from the left side is -2. So down here, we'll do this in red. -2 means this. And these two are going to have to connect, right? All right, and then it says limit as we approach 1 is 2. And I don't think that's straight. I think that's super inclined. And then it says it doesn't exist. So guys, you can't fill in either circle at -1, okay, to make this condition true. Then it says, hey, we have a point at the origin. Woo, big deal. And then it says at 4, it goes to infinity. There. So everybody, there it is. I know for a fact, listen carefully, I know for a fact on the answer key I misread this, and I put that dot right here. No, I didn't. I put that dot at 2 over here. But that's all right. I could have done that too. I just would have missed this point. All right. Everybody, limit conditions. This is in chapter 2 review if you look there. All right. Tell you what, we'll do the last one. A hypothetical square shrinks so that the length of the sides are changing. They're changing at a rate of 7 meters per minute. At what rate is the area of the square changing when each side is 10? It has to be -7. It said shrinking. So area equals L squared. I will tell you that it says dl/dt. If it's shrinking, you pick the sign. You pick the sign. So I think it's that. It's saying, hey, find dA/dt when L is 10. That's the unknown. Everyone, I assume we know this formula right here without me going into great details. And everybody, oh, look, I have dl/dt, I have dA/dt, I have L. Let's just take the derivative because I think it works out just sweet. And we do implicit differentiation, then we divide by dt. And then I get what? dA/dt equals 2 times 10 meters times -7 meters per minute. Oh, look at the units become. Holy cow, meters squared per minute. It's almost like it's area per minute. How about -140? And that's dA/dt. And we would expect the rate of change in the area to be negative since the side is shrinking. All right? All right. This would be a pretty low level related rate. We all agree? But we like the shape ones. We like circle ones. We like triangle ones. We like square ones. The good practice ones. Okay? All right. Keep practicing. Calculus is really fun.